Hi friends, in today's section we are going to determine the natural frequency for the given system. So the system I have drawn here, which is having one mass attached to the string, and see here, this is the mass which is attached to string. This string is wound around one drum or disc which is having radius r, having mass capital M, and that string is fixed to other end having the spring K. So to solve this one, we are going to use the energy method, because this problem is simple to solve with the energy method. So in the energy method, we have seen earlier that the energy during the vibration, that is going to convert from one form to another form. Suppose from potential energy to kinetic energy, and again from kinetic energy to potential energy. And when it is going to convert from kinetic to potential, at any position, the summation of kinetic plus potential always remain constant. So that we are going to use here. So from this system, when this mass is going to displace by distance x, then this drum is going to rotate because of the displacement of mass. Means mass is going to displace, so it is having kinetic energy. Along with this, drum is going to rotate, so it is having kinetic energy, circular kinetic energy, means rotating kinetic energy. And this spring is going to stretch, so it will store the energy in that spring, that is the potential energy stored in spring. So in this problem or given system, we have three different energies: kinetic energy of mass, kinetic energy of drum, and potential energy stored in spring. So I can write total energy in this system. I have represented this one by using T. So T means total energy is equal to kinetic energy of mass, that is mass M, plus kinetic energy of drum, that is the rotational, plus potential energy stored in the spring. So when I add all these energies, then this energy will remain constant during the vibration. So I am going to write the kinetic energy of drum, mass and spring. Now the kinetic energy of mass, it is going to displace by distance x. So the kinetic energy will be 1/2 mv square. This is the formula to calculate kinetic energy in the linear system. Then kinetic energy in drum is 1/2, but it is, will have to write in circular because it is going to rotate. So I am going to replace this formula into the angular. So instead of mass, I will write mass moment of inertia I. Mass will be replaced by I, mass moment of inertia mk square, and V will be replaced by omega, angular velocity. Okay, so the formula is same. First one is represented in linear and second one is represented in angular. So 1/2 I omega square plus potential energy stored in spring, that I am going to write by using 1/2 kx square. Now how to find this potential energy, that you can see here in the left side in the box I have written. I have taken it from the machine design topic. In that machine design, there is one topic, that is spring. So spring force is always proportional to displacement. So F and X are proportional. So this is the straight line. And area under the curve is nothing but the energy stored in the spring. So area means this triangle area, which is the energy stored in the spring. So triangle area is 1/2 base into height. So the base is X, height is F. So 1/2 base X into height F. But the spring force, that we can write by Kx. F is equal to Kx, that is the spring force. So this formula becomes 1/2 Kx into X, that is 1/2 Kx square. So this is nothing but the energy stored in the spring. So I have written this formula here, the potential energy stored in the spring. Now I am going to modify this equation. To modify this equation, see 1/2 m in vibration we represent displacement by x. See on the left side you can see here displacement is represented by x, velocity is nothing but dx by dt, so it is first differentiation of x with respect to time, that is x dot, and acceleration is nothing but dv by dt, so it is the second differentiation of displacement, so it is the acceleration. So I am write this equation in the form of x. So mv means it is the first differentiation of displacement, that is x dot with respect to time square plus 1/2 I is nothing but mass moment of inertia. I am going to write that I is 1/2 m 1/2 m k square, but the mass that will have to use, this mass will be of that particular drum. Okay, so for the drum the mass is capital M, so 1/2 m r square, this is nothing but the mass moment of inertia. So this mass moment of inertia, again if you see on the left side, just I will show you the mass moment of inertia. Normally we write as I is equal to mk square. So from the third one you can see I is equal to mk square, but this is normally for the hollow portions. Hollow portion means, suppose if I consider the flywheel, for flywheel we can write I is equal to mk square, but in the problem they have given us one disc. So for this disc if I want to write, then it will be 1/2 mr square. If it is hollow then it is mr square. If it is solid means disc, then it is 1/2 mr square. So I is replaced by 1/2 capital mr square into omega square. Here you will have to mention that this small m is the mass of this mass, okay, and the capital M is the mass of disc. So while representing this, here we have to write the m, because this is the mass moment of inertia of disc. Okay, plus 1/2 kx square. Now in this problem you can see V is represented by x dot, so the omega will be represented in the angular. So when I am going to represent into angular, then the angular velocity is dx by dt. Okay, so we will have to represent it by theta. So I am going to replace this omega square in terms of theta. Okay, so V x dot omega, it will be theta dot square. So this is the differentiation of d theta by dt square. Now in this equation you can see we have x, we have theta, we have x. So we will have to replace either x with respect to theta or theta with respect to x. So to replace that, see I am going to draw this drum again here. So this is the drum. Now in this drum, suppose this is the initial point I have considered. Now when this mass is going to move by distance x, ultimately this point will be moved by distance x. So the arc which is moved by this point will be x, and the angle turned in between will be theta. So when this mass is going to move by distance x, this drum will be rotated by angle theta. Now we want this x, and this x is nothing but the arc of that particular disc. So arc is equal to, how to represent arc? We write arc as radius into angle. So it is r into theta. So I will write this as equation 2. Sorry. So we have the relation x is equal to r theta, and we have the total energy. So put this value of 2 in 1. So put this value in equation 1. So when I am going to put, then the total energy will be 1/2 m. Now write the value of x dot. See, x is r theta. So x dot will be r theta dot. So this is the value of x dot square plus 1 half into 1 half mr square, capital Mr square, into, right, theta dot. See, we are transferring x into theta, so there is no need to change this theta. This theta will remain as it is, plus 1 half k into x. X is nothing but r theta. So r theta square. So r square theta square. Okay. So I have converted the equation 1 into one form, that is x and theta will be converted into theta. So I have the equation in one form. Okay. Now I will rewrite the equation with some modifications. So this will be half, this is the small m, then r square theta dot square, I have written the square separately, plus this is 1 by 4, 1 half into 1 half, 1 by 4 into capital M into r square theta dot square plus 1 half k r square theta square. Okay. Now we have equation in the form of theta dot. Okay. Now we'll transfer this equation into theta double dot. Now how to transfer this equation in theta double dot, and why I am transferring this equation into theta double dot? Because normally the vibration is with SHM and the differential equation of SHM is having x double dot or theta double dot. So we'll have to differentiate this equation. So differentiate above equation with respect to time. Now differentiate this equation with respect to time. Now by energy method, the total energy T is constant. So take the differentiation of constant. Differentiation of constant is 0. Now take the differentiation of this one. 1 half, this value is constant, small m it is constant, radius of drum is constant. So all these values are constant. Now take the differentiation of theta dot square. So it is 2 theta dot into theta double dot. Differentiation of theta dot square is 2 theta dot, and the differentiation of theta dot is theta double dot. Plus similarly we will write for the remaining one, 1 half capital M r square, this is the constant. Take the differentiation 2 theta dot into theta double dot. Okay. So theta dot square differentiation is 2 theta dot, and for theta dot it is 2 theta dot plus 1 half k r square, it is constant. So take the differentiation of theta square, 2 theta into theta dot, theta square 2 theta, and for theta it is theta dot. Okay. Now I am going to simplify this one. So to simplify this equation, 0 is equal to, this 2 will be cancelled, here 2 will be cancelled, so it will become 1 half, here the 2 will be cancelled, and we will take the common term. So in all equation you can see theta dot is common. So take theta dot common. So when I take the theta dot common, this equation will remain small mr square theta double dot, because theta dot we have taken common, plus here it is 1 half capital M r square theta double dot, taken theta dot common, so this theta double dot. So next one is k r square theta, we have taken theta double dot, sorry, theta dot common. Okay. Now transfer this theta dot on the left side, so it will become 0. Now the equation will remain m r square. From this 2 I will take theta dot common, so this will become 1 half capital M r square into theta double dot. So I have taken the theta dot common from these 2 plus k r square theta. Now to convert this equation into standard form, that is x double dot or theta double dot, I'm going to divide this equation by this total term. So divide this equation by this total term. So 0 is equal to, this will become theta double dot, plus we'll have to divide by this total term. So 0 divided by that term is 0. Theta double dot divided by this term, this will be cancelled. So it's this remain theta double dot. Here it is k r square divided by m r square plus half m r square, okay, into theta. So when I divide by this total term to all these terms, then this will become kr square divided by this term. Now we will simplify this one. So 0 equal to theta double dot plus, here you can see r square is common in denominator and numerator, so I will cancel the r square. So cancel this r square term. So when you cancel this r square term, this will remain k divided by m plus 1/2 capital M into theta. Now this is the differential equation of system. Why this is the differential equation of system? Because this equation contains theta double dot, that is d2 theta by dt square. Now we'll compare this equation with differential equation of SHM. Compare with differential equation of SHM. Why we'll have to compare this with SHM? Because the vibration is with SHM, and in SHM the differential equation is linear form is x double dot plus omega square x is equal to 0, and if you convert into angular form, it is theta double dot plus omega square theta is equal to 0. Yes, we have replaced x by theta. So compare this one. See, here we have theta double dot, here we have 0 0, then here we have theta, here we have theta, means this omega square must be equal to this bracket. So omega square must be equal to this bracket, that is k divided by m plus 1/2 capital M. Okay. Now take the root from, if I want the value of omega, then we'll have to take the root. So take the root. So the equation will become omega n is equal to under root k divided by m plus 1/2 capital M. And this is nothing but the natural frequency, circular natural frequency of the given system. Okay. If I want the frequency, then the frequency formula is Fn is equal to 1 divided by 2 pi root k by m. K by m is omega n, so I can write omega n here, k divided by m plus 1/2 capital M. Okay, this is the frequency. Okay, so I'll revise this one more time. Just see quickly. I'm going to revise. This one. In the system, they have given one mass attached to string. That string is wound around one drum, that is disc, and attached to one end having spring. So by energy method, there is kinetic energy of mass, kinetic energy of drum, and potential energy stored in spring. So I have written kinetic energy of mass, drum, and potential energy. Kinetic energy is nothing but 1/2 mv square converted into drum, 1/2 I omega square, and potential energy is 1/2 kx square, that is shown on the left side. Then the given equation is converted. V is in the form of x dot, omega is in the form of theta dot. Then we find out that the relation between x and theta. So this x is nothing but the rotation of that particular drum. So we have considered one point to another point, that is the displacement x is equal to r theta. So we have replaced x is equal to r theta in the equation 1. So the total equation will convert into theta. Then to get the theta double dot, we'll have to again differentiate this equation. So differentiate with respect to time. Then the simplification. In the simplification, we have converted into the standard form of differential equation, and that standard form of the differential equation is compared with the differential equation of SHM, and finally we got omega n is equal to under root k by small m plus 1/2 capital M. Thank you.